Okay, let's work through an example. In this case, I have some data built in, so let me go get that. So I put all 7 of my variables in their low state and observed the output variable. Then I put these 3 in their low state and these 4 in the high and observed again and so forth, and filled out my matrix. Now let's then click Calculate. And what this brings up is what some people call a scree plot. I kind of tend to favor optical f-test. The idea is that usually there will be an elbow here. Scree is the rubble at the base of a cliff. And so we look for the rubble down here. And we think, okay, it looks like D, F, and B are active and E, A, G, and C are not. Now at this point, we do not know whether we're seeing D or one of these two-way interactions. We don't know if we're seeing F or one of these two ways, or B or one of its. But we will do some detective work based on the structure of the interactions. Plackett-Burman, who developed this, found a very orderly set of interactions, or a construction that produced that, and we'll use that to advantage. Let's go to round 2. Okay, all of my signs have flipped. Note that all of the signs of my interactions have flipped. The signs of my main effects have remained constant. So I'll get another set of data, and I'll click Calculate again. Okay, once again we see D, F, and B above the elbow, and we see E, C, G, and A below. Now, we've seen these weak variables down here in the mud twice, so that's good enough for me. We will eliminate those. Now, the other thing that has gone on is we've got some things highlighted in yellow, and the ones highlighted in yellow are unlikely to be the active variable. So I can highlight those and get rid of them. I can highlight those and get rid of them. And I can highlight these and get rid of them. And how did we arrive at that? It's very simple. As I flipped the signs of my interactions, I watched to see if my coefficients flipped. And if they flip when I flip the interactions, well, probably they're interactions. If they don't, then they're probably main effects. So I can go down here to 3, and there are several different ways to get this into a state that you need, but the one that happens to fit this particular set of data is that I flip everything except B. And what that will do is it leaves BD negative. I suspect that that's my interaction because I've got both B and D as main effects. It's more likely than either of these other two. And I'll get a new set of data and click Calculate, and QuikSigma will say, yep, you guessed well. It's not AG, it's not CE. Your model is B, D, and the BD interaction here. So probably my next step would be a 2 to the k factorial as a confirmatory, running with just those few variables. Now, the question you might ask is, what will I do if I have only 6 variables instead of 7? Well, the answer is you just take one of these, probably G, and ignore it. And then you know in advance that in the scree plot and in the coefficients, G is going to come up with a 0 coefficient. Similarly, when we get over here in the 16 run mode, I may only have 12 variables, so I may leave 4 of these inactive. Now, the nice thing about this particular design is that it will almost always give you a more clear result with less work than doing something like a quarter or an eighth factorial in the 2 to the k factorial table. So this is our recommended way of doing it and the way we set it up in QuikSigma. Better results, less work.